In stats, we wrapped up a combination of random variables. So we were on this page right here, wrapping up Pete and Aaron's tours. So what you might need to do before we start this problem is flip back and forth between the previous page and this page and write down mu x passengers, sigma x passengers, this is for Pete, mu y for Aaron, and sigma y for Aaron. So those were typed on the previous page. If you're lost, it should be 375, 1.0897, 310, and 0.943. And we need those. And the reason I know we need those is because the very top of this problem, it's talking about number of passengers, not money. But it asks about total amount collected, not profit. So I'm going to totally ignore the out-of-pocket cost. And I need to write a function based on 150 for Pete and 175 for Aaron. So I would say total collected is 150x plus 175y. All right? And the mean is super easy. All you do is you plug in the mean. So type that into your calculator, and you have the average collected amount for Pete and Aaron combined, which comes out to 1105. Standard deviation is a little harder to do because you need to square everything in that function. So first we're going to end up square rooting everything, but to combine them I need to square everything. So I'm squaring that 150 and the 175, and I'm plugging in the standard deviations in place of x and y. And you can type that in one long line. That is A-OK. And you should end up with 232.27. I'll rewrite that too. All right. That's question 1 about collected. It asks for the difference between the two. So if you look down in your handout, you can skip quite a bit of steps if you showed all your work on this step. So down here, it asks for the difference. Pete minus Aaron collected. To get that mean, that function changes to this. So you still have 375. Whoops, I should say this, sorry. The mean difference is when we plug in mu. And we use all the signs that are typed in the function. We don't change anything. And we end up subtracting and getting $20. So I would say something like, on average, Pete collects $20 more than Aaron. All right. Standard deviation there is actually no work required. Because when I calculate this, and you don't have to do this step if you don't want to, you can just draw an arrow and say standard deviation does not change. It is still 232.27. But what you do is you go 150 squared times 1.08 squared plus, I know there's a minus sign in there, I'm going to use that coefficient and square it. So negative 175 squared. So no change. We get the same exact standard deviation. All right, so I know on average the difference in collected amounts is 232.27 from the mean. All right. All right, one last problem. We're done with this massive packet. This one is about tea and putting sugar in your tea. This guy, Mr. Starnes, he thinks that his tea tastes right if it's between 8.5 and 9 grams. I'm going to write needs, must be between 8.5 and 9 grams of sugar. I know the distribution of one sugar packet. So let's call that X, one packet. They describe it in that sentence up there as normal with a mean of 217 and a standard deviation of 0.08. So obviously, on average, he's going to he'll have too little sugar if he puts one packet in. So up here, you see he puts in 4 packets. So let's write a new function, total. And this is where you could possibly go wrong. The mean will probably end up working out, but the standard deviation, depending on how you write it, could go wrong. We want to write it very simplistic like this. Not like this. So you don't have to write the 4x part if you don't want to, but yet I do think it's important to notice that this equation, x1 plus x2 plus x3 plus x4, is not the same as 4x. Because we have independent packets of sugar. If you write 4x, that's like you're ignoring the variability of each packet. All right? You would do 4x if maybe you were converting grams to ounces or something like that. So since I have 4 individual packets, I'm not allowed to write 4x. I have to represent each packet. Now the mean, when we calculate the mean for the total, it is going to be 4 times 217. But that's because 217 plus 217 plus 217 is the same as 4 times 217. So you're safe there. You would get the right mean, which is 8.68. But the standard deviation is where you would get a different result. So what you need to do is square root 0.08 squared 4 times. This is not equivalent. You don't have to write it on your paper. This is not equivalent to this, which is why that would be a bad function to have. All right? So I end up getting 0.16. And now I'm ready to go. I've adjusted my problem. I know that this total is normal because one packet is normal, and I have its mean and standard deviation. The question, I almost wrote it up here, is 8.5 to 9, and I need to find 8.5's z-score. And I need to find 9's z-score. I need to grab my calculator and do normal CDF. Negative 1.125 is the lower, 2 is the upper, the mean is 0, the standard deviation is 1, and I should get for a final answer 8470. Very likely that Mr. Starnes' tea is going to taste right. All right, y'all have a good one. Bye.